All right, here's another linear programming problem. Sometimes it's called a maximization problem. So with that said, let me read the problem here for us, and then we're going to try to graph it and see how we can put it together, maybe our answer. So it says a cookie factory can prepare at most 200 tins of cookies each day. Each large tin requires 2 pounds of butter, and each small tin requires 1 pound of butter, with a maximum of 300 pounds of butter available each day. Large tins sell for $6 and small tins sell for $4.80. Find the maximum profit expected in a day by that factory. Okay, so if we look at kind of what they give us here, we have a few different things. First off, we can make at most 200 tins of cookies, whether we sell the small or the large. All right, so I'm going to make my X. I'm going to call X maybe small, and my Y I'm going to say is large. All right, now in this top box, I'm going to say this is the number of tins. Okay, so the small tins plus the large tins has to equal 200, or it could be, I guess, less than that. That's how many the factory could make at most. So I'm going to say X plus Y, small tins plus large tins, has to be less than or equal to 200 every day. That's this first part. All right, then it says each large tin requires 2 pounds of butter. So we have tins, and my other kind of thing I'm considering here is the amount of butter in those cookies. All right, so the large tin, requires 2 pounds of butter, and the small tins require 1 pound of butter. So here I'd say maybe 1x for the small plus 2x for the large. That has to be less than or equal to, and it says how much butter is available? Well, 300 pounds of butter is available every day. So this has to be less than or equal to 300 pounds. All right. Now, a couple other things to consider is this factory wants to make money. So I'm only going to use my first quadrant here. If you remember quadrants 1, 2, 3, and 4. I'm only use the first one because we want our profits to be positive. You can't make negative cookies. That doesn't make sense. And so you might also consider that X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Right, let's graph all this stuff now. And I think if we count maybe on our graph by 50s, since some of these numbers are a little bit large, that should be helpful. So I'm going to mark up my graph here, and I'll show you what it looks like in a second. All right, so I got my graph all marked up. Because 300 is my largest number that I see here, I went out to 300 on both the X and the Y axis. All right, now it's just a matter of graphing these things. And in both cases, for the number of tins, either X, if I cover up the Y, so on the X axis, X could equal 200, or if I cover up the X, Y could equal 200. All right, so my first line at 200 on both the Y and the X axis here, I am going to draw a line that represents the number of tins. Okay, now I am freehanding this. If you have graph paper, it'll be a little bit more precise. You can see exactly what those points are. But anyway, it's going to be just a line like that. All right, the next equation that I have is 1x plus 2, oops, that should be a y. 1x plus 2y is less than or equal to 300. Okay, and so for this one, at 1x, if I cover up the y term, x is going to equal 300. So out here, I'm going to put a dot at 300. And similarly, if I divide both by 2, right, 2y equals 300, divide by 2, y is going to equal 150. So on my y-axis at 150, I put a dot there, and I'm going to connect those two, and that's going to represent the amount of butter that each of these cookies would take, right? Just like this, okay? So we have a couple of things going on here. First off, these are all less than, so if I plug in zeros, 0 has to be less than that, 0 has to be less than 300. So it's going to be shaded down, but I also have these other two equations because we want to be profitable. So on my x-axis, on my y-axis and my x-axis, both of those, we want those to be shaded this way and this way, so kind of in that region. And each of these is going to be less than, less than, less than, less than, less than. So the region that contains all of this is this right here. This is what you would shade on yours. And at the corners of that shaded region are going to be where we could potentially have our maximum profits. So either this point right here, which is the point 0, 150. I'll put my options over here, maybe 0, 150. At this point, which is 100, 100, 100, 100. this point, which is 200, 0, or I suppose you could also say 0, 0, but that means we didn't make any cookies, and so that, of course, is not going to be the most profitable. Now, the only thing I haven't talked about is our objective quantity, and that's going to be how much do these sell for. So the large tins sell for $6 and the small tins sell for $4.80. So if you remember your X and your Y, small was our X, and so we're going to say 480X, 480X plus 6Y, 6Y should equal our profit, which I'll say is P. All right, so we have a bunch of XY points here. I'm going to plug those in, and we're going to see what that gives us as an output. All right, and the first one, 0 times 480 will be 0, plus 6 times 150. 6 times 150. Might have a calculator handy for this. This gives us, I'll put over here, a $900 profit. Not bad. All right, what about the 100, 100? If I plug those in, 480 times 100 is 480. 480 plus 600 is $1,080. So that's a little bit more. So that's even more profitable. What about 200, 0? So the 0 goes with the 6. 200 times 480. 200 times 4.80 is 960. That's interesting. It's more than that first one, but this one is still the best. And then if I plug in 0, of course, we didn't make any cookies, so this would give us a profit of 0. So the one right here, $1,080, if I make 100 small and 100 large cookies, or large tins of cookies, would be the maximum profit that cookie factory could expect to make in a day. So that is how you do some linear programming problems. You gotta start with some constraints, graph it, find the regions where it's bounded, and at the corners of those could be your potential maximum or minimum profit per day.